In this video, we'll be talking about scientific notation. We'll be talking about what is scientific notation and how do we convert the decimals into scientific notation. So scientific notation is basically the way of expressing very small and very large numbers by the power of 10, and it is also known as the scientific notation is also known as standard form in the United Kingdom. So every time if you hear the word scientific form, it basically means uh, not the scientific form, the standard form. Every time you hear the word standard form, it basically means the scientific notation. So why do we use scientific notation? Well, you see, in science, in mathematics, physics, chemistry, in every field, when you are trying to measure something, we most of the time deal with very large numbers, very large quantity of numbers, both both large and both very small numbers. So instead of writing 0 0 0 0, count many zeros, we convert the decimal into the standard form, the scientific notation. So for example, let me give you an example. So for example, the mass of earth the mass of earth is 5.972 multiplied by 10 power 24 kilogram. And you can see how big this value is in 10 power 24, which basically means one followed by 24 zeros. So instead of writing one and then with 24 zeros, instead of writing that, we convert it into 10's power, which is now 10's power 24. And another, this is the example of very large quantity, the mass of the earth. And now at the same time, an example of very small quantity, for example, the mass of electron. The mass of electron, so the mass of electron is 9.109. I'm just gonna stop it here. 9.109 multiplied by 10's power minus 31 kg. Now, as you can see now here, that instead of very large quantity, we are dealing a very small quantity here. So that is the thing here. If there it's giving us 10's power minus 31, which basically means that when you insert a decimal point, then after that you have to write 30 zeros, and then you have to write this value to get the mass of an electron. So instead of writing huge volumes of zeros, a huge number of very large number of zeros, just write it down. Maybe it will take one or two, three lines of a page. Instead of writing that, we convert it into the standard form, the scientific notation. It's also very because of the convenience, we use the scientific notation. So so the international accepted practices, there are some rules here in order to try to convert the decimals into scientific notation. So one of the rule is that rule number one, where is it? I think I should write with green here. Rules. So the rule will be that here, that the first digit that we write on the left side, from we write the notation from left to right. mm, so the first digit here, for example here, the first digit, it should be a non-zero digit. So first digit will be non-zero, and only one digit, which basically means 1 to 9. You can insert the digit that is from 1 to 9. You cannot add two digits, for example 10, 11, 12, some or beyond that. Only one digit, and that should be non-zero. That should not be zero, and it should be 1 1 1 1 to 9, between 1 to 9. So the powers can be both positive and negative. As you can see here, the mass of the earth is huge, 10 power 24, which is a positive here, and mass of electron is 10 power minus 21, which is really small. So basically 10 power positive integer means, positive basically means that it's greater than 1, and minus basically means smaller than 1. Here it's greater than 1, and maybe few of you will be asking, so what about something that is equal to 1? Here I am saying greater than 1, smaller than 1. Can there be equal to 1? Well, that it is. Where should I write? I think okay, I'll write it with yellow in the brackets. Now for example, tens power, I said only positive. Now for thing that should be equal to 1, we know that something's power 0 will be equal to 1. So tens power 0 will be equal to 1. So, and when you try to go above it, for example when you are positive 1 2 3 4 and beyond that, then we already know that the power that it is greater than 1. But when you are talking about tens power minus, it becomes smaller than 1. For example 0 0.1, 0 0.00000001, and so beyond. Now let's try to take some examples. Let's try to take some random values and to convert them into, and try to convert them their decimals into standard form. So first, I think I should write here decimal. We will try to convert decimal to standard form. Maybe throughout the video I I will write standard form, but you basically know that standard form is scientific, basically means scientific notation. So first of all, what we will do is, as I have said here, greater than 1, smaller than 1, we will try the same thing. We will categorize it. First we're gonna deal with values greater than 1. So first we will deal with values that are greater than 1. Now let's take some value. Let's take a simple value here. For example, let me write 30,000. So I have write 30. Oh, I'm sorry, my mistake. 4 zeros. 30,000. Now how do we convert it into scientific notation? So well, let me use the color blue here. Now first of all, let's check the rule. It says first digit will be non-zero. So what is it talking about? What's the first digit? Well, basically you will see, as you already know, this is also the rule. If we will go from left to right, so what is the first digit here? From left to right, we have the first digit 3 here, so we're gonna write down 3. And then and then when we have wrote the digit here, we already know that we cannot write another digit, because only one digit is allowed. So what we will now introduce a decimal point here. Now we have zeros here, so so the rule is that if you have all the zeros here, no non-zero here, then we will only introduce one zero here, 3.0. And then we will use the multiplication sign here. 3.0 multiply, I'm sorry, I will say it as O, but it is actually 0. 3.0 multiply, well, just I'm just let go of the O here, and I will say 0 for your convenience. 3.0 multiplied by 10's power, and then we will write 10. And then how do we write the power of 10? Well, it's simple. Now, for example, for arrows, for explaining, I will write the arrows, the direction of arrows, and I'll use the green color here. Now we will now after this we will check how many digits are there. It doesn't matter if they are zeros or there are non-zeros. We will let go of the very first digit. We're gonna let it go through it to the side, and then after that we will count every digit, the number of digits that are present here. So here we have 1, 2, 3, and 4. We have 4 zeros here, so that the total number of digits will be the power of 10, which is here we have 4, so we will have 10's power 4 here. So these will be total digits, the total digits after 3, after the very first digit, and we have 3.0 multiplied by 10's power 4. So this is a very simple example, a very simple value. Now let's take another value here, a big one. So we will take here, we'll take 138, okay, 138 0 0 0 0 0 0 0 0. And this value is actually the age of our universe, the approximate age of our universe since the Big Bang. So I will write years also here. So this is a pretty big value, and we will do the same thing. For example, let's try to remind what we did in the very first example here. We wrote the very first digit as it is, so we will do the same here. We will write 1, and we will introduce a decimal point. Now this is also the rule, and I will write it down again. So first digit will be non-zero, and then introduce, just gonna write the decimal point after the first digit. And now here now we have write down the 1.0 Now instead here we have wrote 0 because we only had zeros here. We only introduced 0 one digit of 0 here. Now here we have 3 8. So instead of now the rule now should be now the rule will be, now after introducing the decimal point, we will write these values in here 3 1.38. Now we will not use zeros here because we already had non-zero values here. So 1.38, now introduce the multiplication sign and then tens power. Now how do we write the tens power here? Because above here we only had 0, we had to count the zeros. So I also told you this at that time also, that we are trying to count the digits here. It doesn't matter zeros or non-zeros. After we have written the very first digit here, we will count down the total number of digits that are present here. So let's just count it out. We will have 1 2 3 4 5 6 7 8 9 10. So we have 10. So there are total number of 10 digits aside from the very first digit here. So 10 digits, and that will be the power of 10. So 10's power 10. Yes. So this is its standard form, the scientific notation. 1.38 multiplied by 10's power 10 years. So I'm sorry, I'm just writing the rules on the fly here, but I think that will, by explaining it to you, I think it will make in a very logical to you. So write the decimal point after the first digit. Now also write the numbers after the decimal point. There are conditions. 0 when all are 0. Basically means this, we will only introduce 0 here if everything on this side is 0, and write number if any. It doesn't matter how much you write, but mostly the common practice is 2 or 3 digits. But for the sake of this video, I will write the whole numbers here, any number which is given. So here we have 1 point and we had 38 instead of zeros. Then we will have 1.38. Here the rule, write number if any. Now your point will be, what if instead of here 38, instead of 38 here, what if we had here, we have an on this side? So it will be very simple. We will write the decimal point here, and we will use zeros also. For example, 38 is here and zeros are there, then we will write 1.00 and then 38, and then we will use the multiplication sign and 10's power 10 here. So here write the numbers after the decimal point, and we will have the final one. These are general rules, so you have to keep that in mind. Now these rules are right now for values that are greater than 1. These are for values that are greater than 1. Write the numbers after the decimal point. So count the number of digits. Count the number of digits excluding the first digit, and write that as the power of 10. power of 10. Here we will I'll introduce you I will explain it through you through arrows here. One as it is, then we will use the decimal point here, and then we have these values here, then we will introduce it here, and then we will use multiplication sign, and then tens power 10. Tens power basically means we will leave the 1 here, the first digit here, and we will count the total number of digits, and these digits will be the power, they will act as the power of 10. Now let's go through another example here. Only how many should I introduce? I think 3 more example. Yep, but the video, I'm sorry, but video will be long now, but you have to buckle up for this because there are a few more examples that I want to explain it to you people. Now another example, this is just the extension of it. 1 6 2 3 9 4 0 0 0 0 0 0 0 0 0 0 0 0 0. I think this many zeros will be enough. Now how do we write it in standard form? Well, rule number 1, first digit will be non-zero. Okay, first digit we already know non-zero, but we will write as it is. 1. Rule 2, write the decimal point after the first digit. Okay, decimal point here. Now here, write the number after the decimal point. 0 when all are 0. After 1, well, these are all zeros, but these aren't zeros. So what we'll do, write number if any. So we will write the whole number here, whole number, the given numbers here, 6 2 3 9 4. Now we will introduce the multiplication sign, and then we will write 10. And what's gonna be the power of it? We will count down in neglecting the very first digit here. This is gonna be a very long one. Okay, 1, how many digits? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So we have 20. So this will be 20 tens power 20. So that's how we write the scientific notation. Now another example of it, this example will be a little bit complex to you, but it follows the same rules as I have written down there. Okay, the next value is 94.000178. Now how do we convert this into scientific notation? Well, we can't use 10 power minus in negative because we already know it's greater than 194 here, obviously. So how do we write? We will follow the rules here. First digit as it is 9, introduce the decimal point 4. Now we will write the number as it is. It doesn't matter if zeros is between them or after zeros are introduced firstly and then numbers come. If there are non-zero numbers, if they are non-zeros, we will write it down. So how do we write? We will write as it is, there of their order, 9.40000178 multiply by tens power. So how do we write this? How do we write the tens power of it? So we will neglect the decimal point here, but we only check this out. This one we will only check this one out. So what it is, only we will neglect the first digit, and we have only one digit here. So that only one digit will be tens power 1. We will not include the point here because you already know the tens power that this value is greater than 1, and point doesn't make any sense of it. If it will only make sense in the in the later topic, in the later category that we will go through. So here we will neglect the decimal here and only focus on 94 here. We will only focus on 94 here. And how many digits are there? For only one digit. If we neglect the very first digit, that is 9, so only one digit, so that will be the power of 1 here. So another example, I think I have to write down here only. So 3.333333. Okay, so how do you write this value here? Introducing, we will follow the rules. First digit as it is, point, introduce point here, and we will write 3. I will only use 3 because we got it, there are only 3 is here there. Multiply by multiplication sign, and introduce 10. And what's gonna be power? As you already know, point here, we will neglect the point here. If value is greater than 1, we will neglect it all. So neglecting this and only focusing on this value. So how many digits after the point, after the after the first digit, neglecting this very first digit, we will have only 2 digits. So this will be the 10's power 2. So that is how you write the decimals into scientific notation. Only when the values are greater than 1, only values greater than 1 we will follow the rules. We will write them as their scientific notation if their values are greater than 1. Now what about values smaller than 1? So we will cover that up. Values smaller than 1. Values smaller than 1. So how do we write the scientific note, convert the decimals that are less than 1 into the standard form? So let me first explain it to you. I think that will make more of a confusion for you. Now, for example, here I have written 10. Now, you already don't know that this, if we write it as 10's power, that will be 10's power 1. Okay. Now, let's say you have inserted a point here, a decimal point here. You already know that if you write this here on the right side of it, it doesn't change the value of it. 10 will be 10 even if you write decimal on the right side or not. 10 will be 10. So what if I did the reverse? What if I write this value in total reverse? So in reversing the value, I will have 0.01. Now we will introduce the 0 here. You already know 0. If I introduce it on the left side, it doesn't make it will not change the value, but for your convenience I write this 0 here. Now I have reversed it. Now you all will be thinking that this will be equal to 10's power minus 1. I think, in my opinion, that will be a confusion for you guys. If you don't have any confusion, then props to you, man. So you will be thinking that 0, if I reverse the values and write it as 0.01, that will be 10's power minus 1, but that is completely wrong. So you are will be thinking, so what's the value of 10's power minus 1? Well, 10's power minus 1 value will be only 0.1, and this value will be 10's power minus 2 will be 0.01, and that is the rule for calculating calculating the total digits of them. When you are trying to find the values that are smaller than 1, it is, you already know that in the values greater than 1, I'm sorry. I'm sorry. Okay. In the values greater than 1, you neglected the very first digit here, and then you have counted the zeros, the other digits here. Well, you will do the same here. You will do the same here, but instead, you already know zero doesn't make does zero if you introduce it on the left side here doesn't make doesn't will not change the value of it, so we will also neglect it out just like we did here. But now instead of writing from here, instead of the digits here, we will also count point as a digit 2, and then we will stop counting till we have another non-zero digit here. Now for example, we have 1 here, so before 1 we have to count the total number, the total zeros there, also including the decimal point here. So here we have 10, that will be 10's power minus 1, but instead of 0 we will also count the decimal point here. So instead of minus 1, that will be minus 2 here. So that's the main point, so that's the main point that I wanted to clear for the values that we will calculate that are smaller than 1. So now let's get started with the first value here. So the first value will be 0.000168. So okay, now there should I write the rules? Where should I write the rules? I think wait a minute guys, I think I should move this. Okay, got it. Now we will follow the rules that are some for the values that are smaller than 1. So what will be rule number 1? Rule number 1 will be same as the other one. Write the digit as it is, but as you already know, general rule will be left to right. We will always go from left to right. This will be the general rule. So so what will be the rule? We will write the first digit as it is, but as you already know that dealing with values smaller than 1, we will always encounter zeros. So we will go from left to right. So we will go from left to right, and we will write the very first value that we encounter when we are trying to search from left to right. So what is the value that you are what is the non-zero value that we are encountering first? That is 1. So that is the digit. Write the first digit that you encounter from going left to right, and then add decimal point. I will not make a point, I will just say add and add decimal point here. So here we are going from left to right, and we have 1 here. We have encountered 1, the non-zero digit, and we will write it as 1. Now the second rule, the same as the first one. Write the decimal point, the decimal point the decimal point, and this will be the same. Write the numbers after the decimal point 0 when all are 0, write numbers if any. So what should I do? Just wait a second. So we will first just let me solve this. 1.6 we will write 1.68. Now introduce the multiplication sign and then tens power 10. Now how do you write the tens power now? So as you already know what I told you here, we will just gonna remove the sign arrow. Now we will calculate the decimals here, including the point here. So we will including the decimal point here, and we will write. We will we will check the number of zeros till we have the very first non-zero, which is 1. So how many have point decimal point? 1, 2, 3, 4. We will write 4 here. Now in case we already know that these are values that are smaller than 1, we are dealing with the values that are smaller than 1, we will introduce the negative sign here. So we will have -4 here. So this is basically the same thing, but in the reverse order here. For example, here we neglected the very first digit here and then counted the decimals here, but instead here we will neglect every other value. The here we will neglect these values only when we encounter the very first non-zero when going from left to right, and that is how we will write its first digit, and then we will write these digits if any are given, and then we will completely neglect them. We will neglect them just like we did here. We will neglect the very first digit, but instead we will neglect, and here we will neglect everything here. And now we will calculate, we will check the how many zeros are here, including the decimal point. So we have 1 in the decimal point. We will also count the decimal point: 1, 2, 3, and 4, and that will be 4 power 10 power 4, and negative sign meaning that these values are smaller than 1. So what I was going to do was, if these are the same, then why not copy? Okay, I can do that. Okay, after the decimal point 0, when all are 0. Now here when all are 0 basically means when all are 0 2, when no value, when you have further no value. For example, what do I mean by this statement? For example, we have given only 1 here. Now let's I'm sorry I didn't went with the very simple example, so I will show you here. For example, we take only this here. Now here our just remember the rules here. Going from left to right, we encountered one digit point. Now here it's saying this thing here: 0 when no value further. Now 1 no value further mean we will go further than 1. We already know there is no value further than 1, then we will introduce the 0 here, then my multiplication sign. Now here we will neglect the 1 here. Now here we have taken 1. If we have taken here, for example, we have taken this digit here, we will write it down. Now including this value, and further down the road from on its right side, we will neglect every value of it, and we will neglect it, and we will calculate the number of zeros here, including the decimal point: 1, 2, 3, 4, and we will have 4 and -4 because the values are smaller than 1. Now another example of it: This will be a bit extreme. Well, not extreme, because two more are there, because that will be more extreme. So 0 0 0 0 0 0 0 0 0 0 0 1 6 7 8 9. So how about this? How do we convert that? We will follow the rule. Oh, we will follow the rule, but I forgot to write that rule. The last will be count the zeros, including the decimal point, till the non-zero digit, the non-zero digit that you write as the very first value in the standard form. Now here we will use the same rules here. Again, we will go from, we'll introduce arrows here for your convenience. We will go from left to right and we'll find the very first non-zero value here. Now 1 here, it doesn't matter it's 1 or 6 or 7, until we get the non-zero value here. We will go, and if when we have the non-zero value here, we will write the first value is it at it is, we will write as 1, and then only one digit or very first digit, and we will add the decimal point here. So second rule, 0 when no value further. Well, we don't have any zero, no zeros or any value further. So we have 6 7 8 9. So right, so the second rule, the second condition, write number if any. 1.6789, multiplication sign, and then tens power. So how many tens power, how many tens power will be? Well, you already know, we already found the non-zero value, so we will wholly just neglect them out, and we will calculate with the number of zeros including the decimal point. So how many it is? So including the decimal point, we have 1 2 3 4 5 6 7 8 9 10 11 12 13. 13 we will write as tens power 13, minus sign, the negative sign, which basically means values are smaller than 1. Let's take another example of it. Another example that is also very extreme. So 0.000000. Where should I write? Let's just don't take it too extreme, just stop it right here. 0 4 5 0 7 8 8 9 5. So this is the value. So how do we write it down? So following the rules, going from left to right until we have encountered the very first non-zero digit, and we have 4. Oh, sorry, as it is, we'll have 4, introduce the decimal point. Now 0 when no value further, but we will write, because they are given, 4.50788895. Introduce the multiplication sign and write 10. Now what will be the power of it? We will calculate the zeros including the decimal point until we have the very first digit that we write here, 4, which is 4. So how many will be? Let's say I made the group of 3 here, so I will first calculate the group. 1 2 3 4 5 6 7. 1 2 4 5 6 7. So 7 group here. 7 multiplied by 3, 3 7 multiplied by 3 will be 21, plus this 0 22, plus the decimal point 23, which is 23, and introduce the negative sign, which basically also means values smaller than 1. And the last example, this last example will be 0.00000333333. So how do you write this down? The same rule, left, going from left to right until we encounter the very first digit, 3 point, write down these numbers, multiply by multiply by multiplication sign, tens power. Now we will calculate, we will check how many zeros are there including the decimal point. 1 2 3 4 5 6 7. 7 negative sign, meaning value smaller than 1. So this is it. How much time did it take? Let's just move this big sign to elsewhere. Resize. Where should okay then, general. Yep. Okay, I think that is that it. This is it. The video has taken too long. It's approximately 50 minutes now, maybe more than will be now more than 50 minutes. And I wasn't this was actually the halfway of it, because actually what I wanted to do is also tell you how to convert the scientific notation into back to their decimal forms. So given the time here, I've taken too much time of you guys, and I think I have to make part 2 of this video also. Then that will be better. That will be better. And this is the video for scientific notation, converting the decimals into scientific notation. And these are the rules. This first one is for rules for values that are greater than 1, and this is the rule for values that are smaller than 1. And it's okay that you didn't get on the first try. You can also replay the video and understand the concept, and you can also take help from other YouTube creators and even from Google or Wikipedia, which you like the best. And I hope you have understood my video better. And I think the part 2, that will be the part 2. The part 2 will be the converting the standard form, the scientific notation, to its decimal form, and that will be the part 2. And maybe the part 3 will be arithmetic operations with the scientific notation. How do we plus, minus, multiply, divide with this scientific, the values that are in standard form? Maybe that will be the part 3. I'm not sure, but the part 2 will be converting decimal form back to converted standard form back to decimal form. So I really hope you have found this video informative, and if you have any comments related to this topic, you can comment down below the video, and I'll try to answer it for you guys. And please make sure to like this video, subscribe to the channel, and share it to other people as well. It really helps the channel. And thank you so much guys for watching this video. and I'll see you guys in the next video. Take care, thank you, and goodbye.